Yay! Here we go. Here we go. Here we go. In front of you are pages that will be remarkably helpful for the next many days. Many days. Also in front of you are a sheet of trig identities. What that means is things that are exactly equal to each other. For example, we will prove that sine squared plus cosine squared equals 1. Say, I see that. All right. Turn your little pages to the page, the penultimate page. Who knows the words penultimate? It means the one before the last. The one before the last. Okay. How about you get some kind of your own notes out to practice with as well. All right. We're going to be doing a lot of arithmetic. However, a lot of arithmetic is going to be with trigonometry. So if you would please, on your sheet of paper, write this down. Oh my goodness, Mr. Hoban, you said this was going to be the hardest we've done in a long time. Hey, everybody, including everybody, what is the denominator of this 5? We need blank into blankinators. We need common denominators. I have to multiply this by 5 over 5 because 5 over 5 has a value of 1. So I get 25 over 5 plus 1 over 5 is 26 over 5. Say, yep. All right. Our directions are going to be to do the operation and then simplify. So if you'd write real example number 1 down, or you could call it example number 2, and I'm going to write tangent, and this is the Greek letter theta. Tangent of theta plus 1 over tangent of theta. Have any of you seen anything recently that looks really similar to that, like in the last 1 minute? Does that absolutely follow the form of when we did 5 plus 1/5? Say, yep. We needed what? We needed common denominators. This really has a 1. So our common denominator is what? Good one, Van. That can be heard on the screen. The common denominator is, say it, say tangent. Everyone please take times tangent over tangent. What is the value of tangent over tangent? Tangent over tangent, use your fingers. It's 1. What's x times x? X squared. Tangent times tangent is tangent squared. And we write it this way. We write tangent squared theta. Do we now have common denominators? Say yep. Over tangent theta plus 1. So we have a common denominator. We have tangent squared theta plus 1. Would you now please take out the singular sheet that you were just given? The singular sheet that you were just given. We're going to focus a lot today on the Pythagorean identities, the one that is in the upper right corner. Do you see something on this sheet that is similar to something you see right here? 1 plus tangent squared is exactly the same as. Second one down, Pythagorean identities. 1 plus tangent squared is exactly the same as. More of you, so the people at home can hear it. Secant squared, secant squared. Is something without a plus easier than something with a plus? Yes? Yep. We don't have to plus. Okay, we are now going to write this in terms of sine and cosine. That's often a good idea. That's the idea we're going to go with here. Maybe. secant everybody is the same as 1 over this fraction line is the same as a side-by-side divided line. What is tangent the same as? Sine over cosine. And by the way, we're always going to keep writing the theta. What is your favorite chicken restaurant?
Popeyes.
Good job, KFC. Keep it, change it, flip it, right? Say yup. 1 over cosine. Do what to the divide by sine? Turn it into a, thank you, and flip it. Say cool. If we had an x and an x squared, could we cross out one of the x's? Say yep. If I got a cosine and cosine, can I cross out this cosine and this one here? That is considered as reduced as possible. There's no pluses or minuses. Things are in terms of sines and cosines. It's exactly the same. It's exactly the same as adding 5 plus 1/5. Okay, all right. Let me look at one like this. So your next little example, it is to perform the operation. So it's to add or subtract or multiply or divide, and then simplify. And I am going to do this. And I'm going to start a new recording.